Hello, I'm going to record quickly how to work with the Excel file. I think I have explained that to most of the groups, but if I haven't, please take a look at this video so that you can work on your Excel file by the Thanksgiving break. So remember that we got this data from PVWatts. I'll show you how to do that. The most important thing is that we have to highlight the ambient temperature. It comes in Celsius, and we have to turn Celsius into Fahrenheit. The formula is this one. It's the Celsius cell times 9 divided by 5, parentheses are important, plus 32. Okay, so with this formula, we have this. And once we have one of the cells, then we can drag it all the way down. And remember that this is a yearly data, so we have a lot of them. We have 8,762 different cells. Okay, so we have to drag this down. Then we need 4 columns here. So these are the thermal loads through walls. These are the thermal loads through the roof. Then we need the thermal loads through the windows. And finally, thermal loads through the ventilation. For the thermal loads through the walls, we always have the same structure. That's the structure of the Excel file to calculate the thermal loads. In Excel, we have to type parentheses, then times, parentheses, times, minus another value, and close the parentheses. Okay, so we always have this one value times another one times something minus something. This is indoor minus outdoor temperature. So for the thermal loads in the walls, you see that we have the first parenthesis times the second parenthesis times something minus that. Okay, so what is the first value that we have to get in these parentheses? We have to go to the Excel file. We have to go to the walls. And here in the walls, we have the U value. Okay, so you have already calculated this. So here we have to calculate this U value. But then we're going to drag it down. So make sure that here we type $, and $, before the letter and before the number. Then the second value is the total area of the walls. So you click here and make sure that we can type $, and $. Then the third value is indoor temperature. The indoor temperature is always here. It's in this cell. So we type this cell and then $, and $. And finally, the yearly data. This is in yearly data. So in this sheet that we have created, and it's the temperature in Fahrenheit. So we type this, and we don't need the $, for this temperature. Okay, so I click OK. And I drag it down, and well, you have to drag this all the way down. Okay, up to the end of the cell. Then for the roof thermal loads, we have the same structure. We have a value times another value times indoor minus outdoor temperature, and the outdoor temperature is always the one from that Excel file. So if we click this, then we have to go to this Excel file, and in the roofs we have to select the U average. Okay, so here we have the U value through the thermal insulation. Here we have the U value from the rafters, and that's the U average. That's the U average. Okay, so we always have to select this wall, and remember $, and $. The second is the total roof area, this one, and $. The third one is the indoor temperature, the same cell here, and $. And then the yearly data is, we have to go to that cell. We have to select again the same temperature. We don't need the dollar here. And then again, you have to drag all this way down. Okay, so you drag this down until the end of this. There's a trick to make it faster. You see that we have to go all the way down, it takes a while. And here, there you go. Okay, and then everything changes. If you write down this last cell, this is 8762 in my Excel file. In your Excel file, it might be different. 8762. I'm going to write it down, and then for the next column, I will write down this number, or I will type this number, and it will be easier. Okay. Anyway, let's do this with Windows. With Windows, here in this cell, we need the same structure. Equals this times this times that minus another parenthesis here. And now, first parenthesis. I have to select the U value of the windows. You have this table for windows. Okay, we have different orientations. In this case, I only have south and west, but you can have south, north, east, and west. But the U value of the window should be the same. So we type this one. So remember here, dollar and dollar. The second value is the total area of the windows. So here we have the area of the western, area of the southern windows, and here we have the total area of the window. So it has to be this one. This is always, well, here, the dollar and dollar. This is always the indoor temperature, dollar and dollar. And the outdoor temperature is on this Excel file, this one. Okay. And now we can drag it down. But instead of dragging all this down, no, I think I have to drag everything down. Yeah, there's no way to do it. Okay, there you go. So thermal loads to the roof, windows, and ventilation. So for this structure of the Excel file, we have equals this, but for ventilation, we're going to do something different. So for the ventilation in the original Excel file, remember that you had first floor, second floor, third floor, and heat recovery efficiency. And here we have the total ventilation loads. Okay, so beside these total ventilation loads, I'm going to type equals this cell divided by, and here I'm going to type indoor minus outdoor temperature, but the indoor minus outdoor temperature in this cell. So this is indoor minus outdoor temperature. So we come up with this value. Why? Because here everything is related to indoor and outdoor temperature. This formula of sensible heat, it was 1.1 times the flow, the total CFM, times indoor minus outdoor temperature. The latent was indoor minus outdoor wet bulb temperature, but well, it doesn't make any difference. So we're going to select where yeah, we have some error here, but it's not relevant. So for simplicity, we're going to do this. We're going to select this, and we're going to select this. We're going to select this cell, and this equals the total ventilation load. With heat recovery, we know that a heat recovery is something that we have to use in order to meet the passive house standards. We select the value with the heat recovery, and then we divide this by indoor minus outdoor temperature. Once we have this, the structure of the ventilation would be equals, then we have that cell that we have just created times indoor temperature minus outdoor temperature of the second sheet. Okay, so that's what I'm going to do now on this yearly data. And this one, I get equals this times this minus. So what is this value in walls? The cell that I have just calculated, this one. The indoor temperature is always this one. The outdoor temperature is always this one. And remember to type dollars here and here. Okay. And then again, all the way down. There you go. Okay, so we're almost there. We have thermal loads through the walls, roofs, windows, ventilation. Exactly the same we have here, but here we only have one value. We have the total thermal load. We have to do the same with 1, 2, 3, 4 different columns and each hour of the year. In this column, I'm going to type total because this is the total value. So I have to add all this up. So this total is equals, well, not equals. I can just type here, create sum, and I'm going to select these 4 values. And okay. Okay, so that I have added all this up. And again, I have to go down, all the way down. There you go. So that's the total, and each cell is the sum of all these. Now, finally, I need the schedule. So for that schedule, we have to type either 0 or 1. 0 means that the building is not operating, and 1 means that the building is operating. So this is up to us. Here we have 1 day. This is January the 1st, and this is from 0 to 23 to 11 p.m. So if we think, that's up to you, it's up to your project. If you think the project is working from, let's say, 6, 1, 2, 3, 4, 5, 6. Okay, if the building is working from 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9 p.m. and then it's not working until 11 p.m. Okay, that's fine. So that's the schedule of your building. So if we assume that all days have the same schedule, then we have to copy this and then we paste it here many times. Okay, so if you do this many times. We are on January the 10th, but now if you select all this column again and you copy at the end of this, and then you copy it again, and then again, so I think we have to work less. But anything, I assume that this is a little boring, but there is no other way to do it. Now, when we have a lot of cells copied, then we can go even faster if we select all these. And then we select this cell, we copy, and then we have copied all the values here. Again, and there you go. Okay, so I even pasted more than I needed. So I select everything, delete. Okay, it takes seconds to do that. And finally, here we have to multiply the total times schedule. So that means that if we have 0, it means that that day or at that specific moment, I don't have any energy consumption. And if I have 1, I have that energy consumption. So that equals this value times this value. There you go. And then, yes, we have to go all the way down. There you go. So this is the monthly energy that we have in this building. Well, the monthly energy, this is what we have to get now. This is the hourly energy that we have in this building. If that building is operating, we have values here. If this building is not operating, so we have 0. Okay. And now we have to create the monthly energy. So we have to go to the transition between January and February. So this is January the 31st, January the 31st. So here between these columns, I insert between these 2 rows, I insert a row and I paint it with the color that it's easy to, yeah, so it's something that stands out. And then on that row, I want to do the sum of all the values that I have here. And this is the January, well, this is the monthly energy loads. Okay, so this is going to be BTUs. So it's a very huge number. It's 235 million BTUs. Okay. So what can I do now? I have to do this every single month. Okay, so this is from January to February. There will be from February to March. Here, I insert another column. I paint it red. Then from March to April, I do have exactly the same element. From April to May, May and June, June and July, July and August. Well, I have all these graphics. This is what I did the other day, but doesn't matter. So then August and September. October. November. And December. Okay. And on all these red lines, I'm going to copy the same formula. So if I copy this cell and the following red line, I have a valid value here. And then I copy this following red line. And so on and so forth. Okay, and the last one is here. Okay, so all this is the sum of those columns, but up to only the beginning of the month here. Okay. So that's it. Here we have the monthly energy. And this is what we need so far. We need that structure. We need the thermal loads in walls, roof, windows, and ventilation. Here we have the total. We add all this up. Then we have a schedule. This is total plus schedule. And then when we have this, we have to select the last row of the month. And then we have to add all these values up. And here we have the monthly energy. And those are BTUs. Okay, so this is all I want for the Excel file. Then, for sure, you have to define materials, and we can even define the indoor temperature. If I type here 72, if I change the area of the southern walls, maybe it's 100, or I can change some materials here. I can add more thermal insulation to the value that will change the, well, it doesn't change because, okay. So if I add more or less thermal insulation here, those values change, as you can see. Okay. So those values change. These can change, and that affect the yearly data, all these numbers. Okay, so once we have the structure, we can change materials, we can change indoor temperatures, we can change window areas or window U values. And here, when it comes to the ventilation, the only thing you need is the number of people. If you don't have a third floor, so the third floor, the number of people would be 0, and everything is changed accordingly. And something that you're asking me, what is the number of people in your first floor or your second floor? It's up to you. Okay, so it has to be something feasible. Depends. It might be 50 people, or it might be 100. I don't know. But anyway, when we do this, all these changes and all these numbers change accordingly. Okay, so the structure is important, and then you can get back to me and I can give you some advice about the materials or the finish. But what is really important is the structure of the Excel file. So that's the first part that we need for this assignment.